Good day to all. Today we are going to see about that single phase fully controlled rectifier but DC separately excited DC motor. See what is the purpose of this single phase fully controlled rectifier of a DC separately excited DC motor. Actually we have to control the speed of this motor with that armature voltage. This is the main concept of this single phase fully controlled rectifier with that separately excited DC motor. Here see we have a AC supply we will get over here. Then we will convert this AC into full controlled rectifier DC separately excited motor. Then we have to control this motor with the help of that armature voltage. See this armature voltage have a external force by excited. Likewise this force also excited by some force. So this is called single phase fully controlled rectifier but DC separated excited motor. Here it has a AC supply over here. Here it's a plus, here it's a minus, and there is a 4 series T1, T2, T3, T4. Here resistance and L inductance and E is the back EMF voltage. First cycle here it is T1, T3 will be a forward bias. Why? Because see here it is a plus and this plus will have a circuit like this. It will go from T1 and it will go here, the current will go here and it will return come over here like this. That time T1, T3 will be forward bias and the T2 along with the T4 is a reverse bias. Why? Because see here it's a negative sign, so it will come over here, then this will be come over here. So that is a negative one. Current will flow Vs positive, that is T1 to armature, T3 to Vs negative. For negative off cycle, this T2 and T4 will be forward bias. If it is, see here, the current will flowing through here. If this voltage will greater than this source voltage, then this will cut off and the current will flow from this inductor to over here. So what will do, this inductor will give the supply to this T3, so it will continue with that flowing of that current, particular current. For that negative off cycle, now T2 and T4 will be forward bias because the sign will be changed like here and there, the sign will be changed. So this T2 and T4 will be forward bias and the T1 along with the T3 will be reverse bias. The current will flow Vs and T2 and the armature, then T4 Vs negative. Likewise the current will flow. See, this is the circuit diagram for that single phase. What I said before, see here it is a positive and a negative, here it's a negative and a positive. So here it is a T1 and T3 will be forward bias and these two will be reverse bias. Here it is these two will be forward bias and these two will be reverse bias. So if you are seeing that waveform, this waveform is a current waveform. This is the voltage waveform and this is mixed with the current and voltage waveform. This is the continuous conduction waveform. Why we are saying this is the continuous conduction means here there is a no zero that takes place come over here because see if it is higher than this source, then the current will flow through there. If it is lower or there is a no supply, then this sign will be changed. Then this will be act as a forward bias. So here there is a no zero value come over here. So it is a continuous conduction waveform from 0 to 5. This alpha A is have a trigger pulse. When the T1 and the T2 will switch on, then this angle will flow like this. Then after that downwards, in that negative sign indicates that if the voltage is lesser than this, then this will occur. Again, if the thyristor will move on to forward bias, then it will come high. Likewise, the voltage and the current waveform will occur. Now we will see this equations. See, V is equal to 1 by pi integral of pi to pi plus alpha. Why it is pi to pi plus alpha? See here, it is pi and it is the pi alpha. So it is the pi to pi plus alpha. That is the limit for this particular equations. So 1 by pi integral of alpha to pi plus alpha, whereas alpha is here. You can see in the diagram alpha is here, pi alpha is here, because here it's triggering a star. So alpha, pi and pi plus alpha. This is the one full cycle, 0 to 5, and pi to pi plus alpha is the one full cycle. So if you see here, we will take that as a limit into Vm sin omega t. Here Vm is a constant, so we will take out that Vm. So the above equation will become Vm by pi integral of pi to pi plus alpha into sin omega t d omega dt. Then if we are integral this sin omega t, it will come minus cos omega t, and with the integral of alpha into pi plus alpha. Then we substitute that limit over here. Then V by pi minus of cos of pi plus alpha minus cos of alpha. If you see, it's like a cos A cos B. So what is the formula for that cos A cos B? Already we know that what is the formula for that cos A cos B? That is cos A cos B minus sin A sin B. That is the formula for that cos A cos B. So we will substitute some over here. Cos A cos B minus sin A sin B. That is the formula for this cos A cos B. We will take as a cos A as a pi plus alpha and cos B as a alpha. See here, the thing is, we take this cos alpha pi plus alpha as a cos A plus B. Then here cos A cos B minus sin A sin B. Here sin A is a sin phi and sin B is a alpha. This minus cos alpha will come here as a minus cos alpha. Then again the next step is V by Vm by pi into minus of minus cos alpha. This cos phi is equal to 0 and sin phi is equal to 0. Cos phi is minus 1. So this minus 1 into cos alpha, here minus cos alpha minus sin alpha is 0. So we will substitute this 0 over here, then minus cos alpha. So this minus will become here minus, and minus cos alpha minus 0, then minus cos alpha. So minus 2 cos alpha, which is equal to Vm by pi into 2 cos alpha. So we will return this Va is equal to 2 Vm. We will take that 2 outside. 2 Vm by pi into cos alpha. What we are knowing about this formula, we will change that alpha, then the voltage will also change. So the final formula here, its voltage is VA is equal to 2 Vm by pi into cos alpha. Thank you.